Hello, folks. Hello. Welcome back to another stream of doing Advent of Code in pure C and just using man pages, no Google, no AI, just us and our computer. This is me, Nobermaster, and let's just get started. Today we'll just try to speed run through everything so that we can catch up to today's problems. Printing department, you ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner to handle the really big print jobs. All this flavor text. Okay. Okay, sure. The forklifts can only access. Okay, wait. Rolls of paper are arranged on a large grid. The elves have located a helpful diagram. You're nearly where everything is located. These are the rolls of paper, and this is empty space, I'm guessing. The forklifts can only access a roll of paper. There are fewer than 4 rolls of paper in the 8 adjacent positions. 8 adjacent positions. Why 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so including diagonals, that's 8. You can figure out which rolls of paper the forklift can access. They'll spend less time looking at and more time breaking the walls to on the cafeteria. Okay, fine. There are 13 rolls of paper that can be accessed by forklift marked with X. Okay. Fewer than 4. Okay. Cool. This is simple. Okay. Let's switch over to our branch. Branch local main create branch starting at main. Call it day 3 or 4. Today's 4, right? Day 4. Okay. Search for a new file. Search for the file called main.c. Sorry, there is one thing we have to change here. Compile commands. I'll include this change later in the main branch, but for now, let's just add it manually. Input file.c, yes.c. Let's get started with today's problem. So input file d file equals input file or parse input file. Okay, and then we have to basically go through every single line and let's change this to line iterator. Okay, and for each of them, what we have to basically do is figure out how many of them are accessible by a forklift, which means that we just have to check whether there are fewer than 4, right? Fewer than 4 rolls of paper in the 8 adjacent positions. Okay, fine. Okay, so I think it's worth first figuring out n. So in the first pass, we just need to figure out n. If file dot lines of or line length of file.numLines -1 is equals to 0, then n equals file.numLines -1, else we have to set n to be equal to file.numLines. So basically the last line can be empty because of the way that the inputs are generated. We are just trying to guard against that. Okay, now we have to have a function called bool include. Does the LSP work here? No. Include standard bool dot h bool, liftable or fork lift bool size t row size t call. Or yeah, that's fine. Row, column. What else do we need? We need n as well. Size t num rows and size t num calls. I guess in the initial pass we can try to do something, which is we can try to check that everything has the same num calls. Size t num calls is equals to file.lines line length of 0, and let's include cs assert. And over here, let's check that assert calls equals file.line length of line I. Okay, so just check that everything has the same num calls, and if that is the case, we can proceed into saying that count equals 0 for size d line I, or sorry, row equals 0, row is less than n, row plus plus. We should rename n to like rename n to num rows. Oh, nice. Using the LSP finally. Num rows. Okay. And let's rename this to row. Okay. And for size t call 0, call is less than we also need to, I guess, pass in star the double array of lines, I guess. Yeah. No, we don't want to set these as constants. Okay. So now we have this. We now want to check count plus equals, or rather, if fork lift liftable, row call num rows num calls, file.lines plus plus, otherwise nothing. Okay, in forklift liftable, we have to basically check all the adjacent positions. So we changed everything to ints, and now what we want to do is basically check that. We want to have another function, roll inbounds. Return 0 is less than equals to row is less than none. Cool. What's up here? Oh. We need to close to terminal. Let's add a terminal here. Well, we need the input as well. $71, is that the answer? Probably not. 13. Do we check whether it's less than 4? No. What's up with this? We don't need a size to here. 1527. How many total rolls of paper could the elves remove if they keep repeating the process? Hmm. Is it always optimal to remove things at the boundaries? I don't know. I don't know the answer to that question. Is it optimal to just greedily remove things? Probably. Hmm. Okay, when we remove things, we never increase the number of things, right? We never increase the right. Yeah, I think that's something we can use probably here. We can just remove things, right? Yeah, that's fine. Okay. I think we want to keep this logic here. We want to just have a buffer, not even a ring buffer, just a normal list buffer to maintain what are all the liftable paper rolls and just lift them. Lift them one by one. Lift whatever is liftable. Yeah. And whenever we lift something, we want to update the adjacent guys. If they are now liftable, we want to lift them. Okay. If they were previously unliftable and now they are liftable, we should lift them. Yes, correct. Um, we don't want to lift something twice or add lib twice to the buffer. I think that's wasteful. So let's be very frugal with how we lift, how we add things to the buffer. So now what do we want to do? Count is here, okay. Forklift, lift. Okay. We're just counting here, so instead of just counting, we want to say that there is a there's a list here as well. What do we want to add to the list? We want to add a pair, ij. We could also add just a size t, which is an encoding of ij, which is a unique index of within the grid. Do we want to do that actually? Instead of adding a struct in? Yeah, I think that's probably the cleanest approach. Sorry, this is completely wrong. Okay. Now instead of counting, we want to just add to the list. We don't even want to do anything to this guy, right? Just treat it as a void star because size t and a void star have the same length, right? Size of void star is the same as uh, size t. So we should be able to just cast it here. Nice. And then finally, sorry, we also have to free the list, right? Okay. Yes. Yes, yes, yes. We're getting somewhere now. Um, while the list size is greater than 0, um, element, okay. What else? New list. Oh, new list is. No, we don't want to do that. Okay, we've just extracted the pair. Now what do we want to do? So it's definitely liftable, right? Now post lifting, we have to check what other nodes we are making liftable. Pair, lines, num rows, or sorry, not lines, list, num columns. Pair, list node d star list, list d num rows. I guess we need more lines as well. I guess this is wrong in that. Now what do we do? Now we have to basically say that if it's exactly equal to 4, then it'll be added, right? Okay. Anything else here? We have to, I guess, also. Well, actually, we can set this to that, but also just remove roll and add. Nice. Hmm? Oh, what is the final task again? How many can we remove? Remove, right? Yeah. That's not correct. Oh, I know. I know what's going on. And that's a lot more than we expected. Mm. Okay, I don't know. I have to go have dinner now. See you in a bit.